what we're going to be talking about today is honeybee sociometry, and I think it's going to be useful, or at least we'll find out if it's interesting for you guys, but I think it's a very useful thing in science, but it's also, unfortunately, something that scientists tend to not do. They tend to kind of skip over it. So this is my information, and this is my actual email. So if you do email me, I will eventually email you back. So we're going to be talking about honeybee colony sociometry and tracking colonies from when they're born all the way through to when they die. So to first kind of define what sociometry is you can take that word apart and split it into socio and metry. And the socio end of it is, you could probably imagine, has to do with social insects, social groups, societies. And the metry is basically measure as much as you possibly can. And a formal description of this is that it's the description and analysis of the physical and numerical characteristics of social insect colonies over their lifetimes. So it's literally everything and anything that you could measure in a social insect colony from birth until death. And this idea of sociometry was actually first coined and first kind of brought to our attention by a lovely man named Walter Schinkel. And Walter Schinkel is actually an ant biologist, and he works with a lot of Solenopsis invicta, the fire ant, the invasive fire ant in the US. And his favorite research tool is the shovel, which is useful because they're quite cheap. And he's a really nice guy, but the basis of this guy's entire career is if you boil it down, is basically digging up social insect colonies and counting everything he possibly can. And that's really what he does. But he wrote a lot of very influential papers, well, influential in some ways and not so influential in others. That he was basically saying to all of us social insect biologists that, look, you're coming up with all these grand ideas of how social insect colonies are organized and how they're doing things, but you're not actually measuring and seeing what they actually do in the first place. It's kind of like a disconnect. In a way, what he called it is that we were skipping a grade, and that we were all interested in how these things were going or how they change within different groups of social insects, but we weren't actually focusing first on what they actually do in the first place. Does this kind of make sense? It's kind of a disconnect. So when he wrote this paper, he said, if this means digging a lot of deep holes, well, shovels are cheap and most of us can use the exercise, which is probably true, and he's definitely dug a lot of holes. So that's Walter Schinkel, and he's a great guy. So this is an example. So you're not meant to read this. Don't even try to read this. But this is an example. In that paper that he wrote, he actually listed all the different things that he could think of someone measuring. Things like, how big is a colony when it's mature? How long does it take for it to get to that mature size? How many sexuals does the colony produce? How big is the territory over which these colonies produce? Remember, he's working with ants, so he's dealing with a whole different beast, but it's social insect colonies, and he very rightly mentioned that this list is not exhaustive, but collecting the data could be exhausting. And it is exhaustive work. And the reason I say that, he said this about sociometry, and it is important, but then it wasn't necessarily always carried through, is that most papers on sociometry are written by Walter Schinkel. So it's kind of like he's definitely put out on a flag that says this is important, but whether people have actually taken it up is a different kind of question. So of course, this, for me at least, came down to, for my PhD, I was very interested in drone comb. And when I think about drone comb and how colonies are building a drone comb, what they're doing with their drone comb, what it all comes down to is it's very important to think about a pattern before the process. So you need to really well describe your pattern before you can get to your process, because otherwise you're kind of putting the horse before the carriage before the horse, or the horse before the carriage. But it's just not the right way to do it. So when I think of colonies and they're building worker comb and they're building drone comb, before I can actually design any experiments that really make sense from a colony's perspective, I need to know things like, when do colonies build drone comb in a natural setting? How much of this drone comb do they build? What is the colony state when they're building this drone comb? And what are colonies actually doing with their drone comb at different points in their life? These are all things that in a realistic scenario, you want to look at what colonies are naturally doing to then kind of understand, okay, what's the process behind those things that they do? And this, you can throw as many questions as you want to there. I mean, there's really an infinite number of things, but in all cases, you really want to have a pattern before you go to the process. So at this point, you might be thinking, well, Michael, you work in honeybees. You're not working in fire ants. You're not working in some mystery species that no one's heard of before. Surely, you're kind of out of luck. Probably someone's already done this. And you are right in some ways, and that is there's been a lot of work done in honeybees. That's all. I mean, I think we can all appreciate that there's been a lot of really good work done in honeybees. But when it comes to actually a sociometric study, it's always had a bit too much of a human slant. And so I'll go an example of like a human slant. Someone's interested in honey production in a colony. So they say, okay, I'm going to take a colony and I'm going to track how much honey this colony produces throughout the year. But they track the honey production in a couple of colonies in a single area, and they don't actually keep track of the number of workers, and they do it in a mature colony in their very large beekeeping setup. So it's not really a connection in the natural biology of a honeybee colony. Because, I mean, we can understand that the number of workers is going to also be related to how much honey the colony can collect. Does that make sense? And so that problem is basically that you're just tracking one parameter. If you're just tracking one parameter, you can't actually see how these different things are related to each other. Another big problem that people do is they use mature colonies. So you'd say, okay, I've got this colony. It's been living for how many longs? It's in 4 supers deep, and I'm going to track something like brood production. How much brood does this colony make? Well, you're looking at a mature colony. You're not really looking at something from when it first starts through when it finally dies. You really kind of have to get it at all stages of their lives. Another thing that people would do, and I can totally understand why people would do this, is they provide combs to the colony. Comb is very expensive for colonies to make. You've actually kind of you've kind of given them a leg up. You haven't actually watched a natural colony development if you don't literally let them do everything themselves. And then the last problem that people do is, and this is a timeline thing, is they often just go through one season. They just take a colony, they go from the summer through the end of the summer, and they say, okay, this is how this has changed, this one factor has changed, and they haven't really taken it for a multiple year kind of to really get the full range of what's going on. And I should definitely mention that to date, when I started, what I was doing, the best one that had been done yet was by Juliana Rangel and Tom Seeley that was published in 2012, and they were interested in a specific parameter about how swarm size influenced colony success, and they did an excellent job, but they did have a couple of the same problems in that they only did it for one season, they provided combs, and they didn't track all the parameters, so there really was, I'm definitely not saying that I'm the first person to do this, I'm just saying that I'm the one that did it best. I'm kidding, I did not do it best. I mean, come on, look at this face. But and this is also the great thing about science. You really can do things another time, and you can kind of it can still add to the literature in interesting ways. So that's kind of where we started. So I'm going to kind of go through what we actually did and how we actually did this, and hopefully there'll be some things in there that you'll find useful. And if not, you can tell me afterwards that you didn't find it useful. But this is kind of where we're going to start. And like I said, it's going to start from swarm until death, so we really do start with swarms. So right here, I don't know if you can tell that these are wooden boxes, and they've got metal screen on there. And we've basically made an artificial swarm, so we've got about 12,000 bees in there, so that's the size that swarms are in the Ithaca, New York region. And we can put a queen in there, and we can basically feed these colonies for a couple days to make an artificial swarm. And this is the way that everyone does any research that has to do with a swarm. They use artificial swarms. So for this experiment, I actually made 4, so I can only do 4 replicates, which has its own problems, but when you see how much data that actually goes into it, it can be quite a daunting task. So this is an observation hive that you can see through because there's glass, and I don't have the covers on it. But if you've seen observation hives, normally they're about yay big, 2 frames. You can't necessarily tell because of the scale on this, but this observation hive is actually yay big. It's about 1 meter by 1 meter. The actual volume inside this space is actually the same volume that a honeybee colony would naturally inhabit in the wild. So what we've got now is we've got swarms of the normal size inhabiting a nest of a normal size. Of course, it is in between 2 glass planes because I need to be able to watch this colony. And so what I do is I take this and I dump a swarm of bees into it. And if you're wondering how you dump a swarm of bees into an observation hive that's got glass, it's a meter by a meter, with great difficulty is the answer. But actually, realistically, what you do is you get the glass and you kind of lean it over and you lean it on your head. And then you dump the bees like this. And then when it's on your head, then you can kind of put it back. And then you have to go through the room and kind of pick up all the leftovers. But yeah, so we can actually install a swarm of bees in there. So now you can see there's actually one side of the covers on there, and the bees have all clustered in there. And they're doing quite nicely. That's a Michael Smith technique right there. And then what you do is you literally just let them do their thing. So at this point, this colony has grown. You can see that they built these combs. They built it right nicely in between those glass panes. So I can actually go in there, and I can, with very, very minimal disturbance, I can measure just about anything I want to. Anything that I can think of, I can say, okay, I'm going to measure this in this colony. And I can do it from the very first day that they've been installed until they eventually die. And I don't know if you'll be able to see, but there's like these grids that have been drawn on this. You can actually say, okay, where are these grids? What number of bees are there? And you may also, if you've got keen eyesight, you might actually see these plastic sheets, which I'll show you another image of. But you're basically just going in there and just watching what these colonies have. Yeah.
Can the bees get to both sides of the observation?
Oh yeah, totally. So the entrance is right out here. They can go in and out. They come in, and there's this comb is bordered on the two sides of the glass. So yeah, they're easy peasy. They can do anything they want to, and they will do anything they want to. So it's a nice exercise in self-control or lack of control. And so in the same way that this colony will grow and develop, these colonies will eventually die. So this is what this colony looks like once it died. This one particularly died over the winter. And even just an image like this, you can really get a lot of information. You can really learn a lot about this colony. You can say, okay, well, here we have the dark area where all the brood was. We can see where the cluster was when they died. You might be able to make out some of the drone comb versus the worker comb. And this is really, it's kind of dissecting a colony from birth until death. And of course, death is part of the story. So yeah, and I quite like these kind of experiments. It's a really simple thing, but I think it's important work to do. And to kind of show you, so you don't think that this is like just on a whim. There's a lot that goes into it. Those plastic sheets that I showed. So you basically put a plastic sheet on that glass, and then you can go in there and you can take with the flashlight. You can actually look in there and you can take a colored marker and you can trace out different things. So I can say, okay, how much worker comb is there? How much drone comb is there? Within the worker comb, how much is honey? How much is brood? Where is their pollen? You can also measure, the number of workers, the number of drones. You do that at night because everyone's at home. But what you end up with is you end up with these plastic sheets, and each color is a different date. And so you take a photograph of that, the best photograph you can, and then you go through and you actually color in with these markers that you can actually, it's on Photoshop, you can actually trace out the different areas. And you can say, okay, this is where there's honey and worker comb. This is where there's honey and drone comb. This is where there's brood. This is where there's pollen. There's some empty comb here. And you really can get quite colorful images of this colony's growth and development. Of course, you do this every single week for 2 years. You also get pretty bored of doing it. But hey, you're a scientist. That's what you're getting paid for. Maybe paid for is an exaggeration, but they're doing something. Anyways, so at this point, and for the entirety of the talk, we're actually going to go through, so you end up with these Excel sheets that have a lot of information. So things like, what colony? So I had 4 colonies, an office colony, a north, south, east, office. So those are the 4 colonies. You have different dates, the experimental day. And so you can say, how much total comb do they have? How much drone comb do they have? How many honey cells do they have that's in the drone comb? How much of the honey is in the worker comb? And I figured what we'd do for this is I would just read out these numbers to you guys. And that's what we'll do for the entire talk. So the South Colony on the 12th of July, 2012 had 608.9 centimeters squared of worker comb. But the next date, they had 111 and 81.1. So we could do that for the whole time if you want to, but I actually figured it'd probably be nicer for us to watch this in a video form instead. But first I'm going to explain what you're going to see, and then I'm going to show you what you're going to see. And if you want to, we can watch it twice because it can go a little fast. So the first thing down here is there's actually like a little time ticker that's going to tell you what time of year, so as it progresses. And what we're going to see is it's going to start with nothing. So in the beginning, there's nothing. And you're going to see that there's going to be like a figure that's going to get larger and larger. That's the actual comb. And then the color will tell you what's in that comb. So if it's empty comb, and by empty comb I mean like you have comb but there's nothing in it, it's going to be gray. If it's yellow, that means there's honey in there. If it's blue, that means there's brood in there. And if it's orange, that means there's pollen. Now these are the well saturated colors. If it's the same color but a little bit lighter, then it's drone comb. And maybe it'll be easier when you actually see it. But I'm going to try. We'll show it once, and we might have to show it twice, just because it really can go by quite quickly, especially in some of the times of year that are really active for a colony. So, and I guess this maybe is a personal question. Is anyone here colorblind? Any of the males? Okay. People who are not colorblind have told me that I picked horrible colors. And part of why I picked those colors is because they're supposedly acceptable for colorblind people. So if you wouldn't mind letting me know afterwards if it actually is real, or if I've just ruined my color palette and I'm not even helping you at all anyways. All right, so we'll take through it. I'm going to try to narrate parts of it, but it will get a little quick. So this is a colony, and it's growing, and you can see it has a lot of brood. And eventually something special is going to happen over here. They've just started building some drone comb. But you notice that they haven't actually done anything with that drone comb. Michael made a mistake here. That's actually supposed to be, we corrected that afterwards. Sometime over the winter holidays, Michael's thinking back home, like, if I'm going to be tracking what's happening in the drone comb, I should also do it in the worker comb. So I start keeping track of the worker comb. It's wintertime. The colony's slowly eating through its honey stores. They've got very, very little brood. But something special is going to happen. It's going to break into spring. We're going to get a lot of brood coming. It's going to get very big. All of a sudden, they're building a lot of more drone comb. They're rearing drone brood. The colony will eventually swarm. They have no brood, but they get a new queen that comes back. It keeps growing. Now we're getting into the depths of the honey flow. We get a second round of drone brood that comes. And eventually, it's going to start looking like Rorschach tests. And we're back into September. And yeah, so that's 2 years of work in about 20 seconds. Yeah, thank you. Do you have
Where's the entrance?
Yes, the entrance is, let me think, the entrance is over here. Yeah, the entrance is over here. Would you guys like to watch this again? I mean, come on, it took me 2 years. All right, so let's see how this goes. So what I meant by the summer thing is that basically I was keeping track really well of the drone comb use, but I wasn't keeping track of all the worker comb use. And it was like an epiphany when it was the middle of winter. I was like, I really need to keep track of both. And that's when this happens. Yeah. So actually, and this is, every time I watch these, I'm always like, oh, there's something cool in there that you wouldn't think of, but it's like in this one when I was just watching, I was noticing that when there was no brood and the colony had just swarmed, they all of a sudden they had a ton of pollen, and then then it kind of it went back. So there's really cool stuff you can do in this. But I think the crux of it is you got to first watch, and if you don't watch, you won't get these kind of things. Okay, so what can you learn by watching? If you take a colony from when it first starts as a swarm all the way through to when it dies, and at least in my opinion, you can learn a heck of a lot. But it's maybe something that other people consider boring, but I still think is interesting and worthwhile. So at this point, I actually want to actually show you the data, the raw data. So some of this might get a little like, oh God, Michael, you're killing us with data. But we can kind of go. I just want to give you kind of some of the data to kind of get an image of what these things look like and what kind of things we can conclude. And the reason I'm going to go through each of the 4 colonies is that they really kind of develop their own personalities. You really get to kind of know these colonies as you're going through them. And please, for clarifying questions at any time, just give me a holler. So here we've got the North Colony, and over here on this axis, we're looking at the population, so the number of workers and the number of drones. And the number of workers will be in black, and the number of drones will be in blue. And so this North Colony, so you can see that it starts here in July, and the very first thing that happens is every single colony just takes a nosedive. I mean, it's the beginning. They've just started a new home. They've got lots of attrition of workers. All these workers are dying, but they're not replacing those workers. And then if the colony is lucky, they actually pull themselves out of that nosedive, and they start to actually grow. This is once actually new workers have been emerging. But what you might notice in this colony is, so this colony did really, really well at increasing the number of workers in that first year. But then, gosh, over that winter, they took a real hard wallop. This colony actually lost 93% of its workers in that first winter. So, I mean, this was a huge number. And so when you can see over here, February, March, April, May, they're really, really in a tiny, tiny number of workers. And because, you're kind of like stepping back, you're like, look, I just need to let this colony do what it does. I need to see what it normally does. I didn't do any kind of manipulation to this colony. I just let them do their thing. So that winter loss was a really hard one. And you'll notice that the North Colony has a lot of odd characteristics. But basically, this is what happens when you have a colony that just takes a huge hit in the wintertime. The East Colony, in contrast, so again, you can see that they take a dip. They kind of grow back up, but they have just a slow, slow loss of workers over the winter. But then once I'm actually able to measure the workers again in April, I'm not actually able to measure the number of workers in the wintertime because they're too tightly clustered. They really go through this really strong growth. Bam, they swarm, they lose a lot of workers, then they take an after swarm, they drop down again, but then they grow, 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 and then they kind of plateau. So this would be kind of like, this would be probably like your traditional, your normal colony. They swarm, they after swarm, they recover, they're doing great. Nicely done. They also invest in some drones. They have a peak of drones, and then it comes down. And of course, the number of drones is not nearly as high as the number of workers, but they do invest in quite a number of drones. The South Colony was another one of these ones that was a little bit tricky. They also died. They kind of build up. But by the spring of the following year, I noticed that their queen had failed over the winter. And because I'm working on 4, and I've already got the North Colony that's not looking so good, I figured, okay, I should probably just requeen this colony to actually keep them in the experiment. So at this point right here with this arrow, anytime you see that arrow, that means that I requeen the colony. And this colony then successfully was able to build up their worker population, but importantly, they never swarmed. So this is an example of like a colony that's kind of in the intermediate. They had a tough winter, but they weren't able to swarm. But they were able to invest in drones. So this would be like a colony that didn't swarm, but could still reproduce via drones. And then the Office Colony, which, like all the other ones, takes a dive, builds up, kind of dies. And then again, just like the East Colony, has a huge increase in population, swarms, drops, builds up again, because you still have all that brood emerging, has an after swarm, drops again, builds up. And then, gosh, what a weird colony. In August, it cast an additional swarm. And then in late August, cast an additional after swarm. And this colony, by the end of September, was in a very bad place. I would call this kind of like a death by swarming. This colony really made some poor life decisions, if you ask me. And they, of course, they also invested in drones in their second year. So if you look at all of these 4 kind of next to each other, I know this can be quite a bit. If I were to kind of like put them into bin categories, I'd say you got your North Colony that's like your child that survived winter, but not really. They didn't really, you survived, but you're not getting a gold ribbon. You have your East Colony that's kind of like your ideal child. They swarmed, they after swarmed, and then they built up to survive that winter. You got your South Colony that's your non-swarmer, some manipulation in there because I did requeen them. They probably would have just dwindled away and died otherwise. And you got your Office Colony that's like your rebel that ended up swarming itself to death. So these are kind of like your 4 children, if you've got children. At this point, you consider the colonies kind of like children if you're spending this much time with them. Cool. So that's just the number of workers and the number of drones in these colonies. I, of course, was really interested in the comb. So the comb is what really gets me going. So I was also, of course, following the comb area. And again, the worker comb will be in black, and the drone comb will be in blue. And you can see that the North colony, did a great job of building a lot of comb right at the beginning. These colonies, when they move into that place, they're really ready to go. They're really rearing to go. They build a lot of comb. And they did build drone comb in their first year, but they kind of plateaued and they didn't really do much after that. They kind of were in a tough spot. And some of these fluctuations that you probably noticed, I'll talk about them later as well, but some of these fluctuations, you can imagine, you got a colony, you got a plastic sheet, you take a photo of the plastic sheet, then you draw on top of the plastic sheet, and then you take that number and that goes into your spreadsheet. There's going to be some wiggle room. So if you see something go up and down, that might literally be because the photograph or something in between. So take everything with a bit of salt. So again, the East colony was another one. Builds up really quickly, builds some of their drone comb in that first year, and then in the second year, gosh, they build a lot more comb. They really fill out their nest. They've done quite a nice job. And again, they also build more drone comb in their second year, and I'll summarize that at the end. South colony, another similar story. We get a lot of comb right at the beginning. They kind of slow down. There's no comb building over the winter time. And then in the next year, they built a heck of a lot of drone comb. This is, remember, the colony that didn't actually, wasn't able to swarm, but they did build a lot of drone comb. And they also added more worker comb in their second year. And the last one, the office colony. Again, this really rapid comb building right at the beginning. They kind of plateau. That continues over the winter time. In the second year, they again build more drone comb and more worker comb in that second year. And then again, they plateau. Around August, September, they stop building new comb. So for me, at least for the work I was doing, because I'm really focused on the drone comb, some of the important things that are based on the basic biology of the bees is that all of these colonies were building drone comb in their first year. But none of them reared drones in their first year. So they're building that comb, but they're not necessarily using it. And this is something that I can also mention at the end, which can change in different things. But the majority of drone comb, if you actually take this amount, you say, okay, at the end of the second year, this is how much drone comb this colony eventually invested in. How much of it was in the first year versus how much of it was in the second year? The vast majority of that drone comb is added in the second year. So 87% of the drone comb is built in the second year versus only 33% of the worker comb that's built in the second year. So when we think of comb building, there's drone comb being built in that first year, but the second year is when the real bulk of it is put in there. And for me, that was important because I'm interested in drone comb at the very early stage of life, and I know that, hey, they will do this in their second year, even though the majority of it is built in the second year. Cool. So now we've looked at the number of workers. We've looked at the comb. Now we can actually look at what's inside of the comb. And so this again is going to have the same color pattern of pollen is in orange, brood is in blue, honey is yellow, and empty is gray. And so for each colony, you can look at their worker comb and their drone comb. And so the area here is actually going to show you the comb area, the amount of that comb that's in each different category. How's this? Can you guys, just so I know, how is this for seeing? Is it difficult to see? No? Good? Okay. Let me know afterwards, because I always make changes to these things, so this is good to know. So again, this north colony, keep in mind that this starts in the winter, partly because that's when I started comparing both worker comb and drone comb. So unfortunately, I don't have these data for the first year. I only have them for the second year in the comb contents for both worker comb and drone comb. I do have the data for just the drone comb in the first year, but of course that's the beachside epiphany in the middle of winter. It's the value of spending some time alone to think about things. So again, this north colony, what you'll see is that they have a good amount of honey coming out of the winter, and that just dwindles, and they do have a good amount of brood in there. But the problem was that they have all this brood, but they don't have the workers to take care of it. The queen's laying eggs, but the workers just aren't there to make it happen. So they're unable to rear the brood that the queen is laying, and also the queen is laying a lot of drone eggs in that worker brood. And it's not that she had run out of sperm. She did have sperm to lay viable worker eggs. But the way I would interpret it is that this colony and its last-ditch effort is still trying to rear some drones to get some reproductive success, and they're only able to actually lay those eggs in the worker comb. So the east colony, again, this is our ideal child. So they have so you can see here that the brood builds. They swarm, and after swarm, you lose all the brood because of that break, and they really build up that brood again. And it's the same thing in the drone comb. So you have drone brood that's built up right before the swarming events, and they have this second development of drone brood later in the year. So for the East colony, we'd say, okay, this is a good recovery post-swarm, and they have that second brood investment. So they really kind of hit their drone comb. They've used it twice in that same year. This is our colony that we had to requeen. And so you can see that this colony really invests in a lot of brood. I mean, they really make a lot of brood, but they never swarm. And they do invest. So this is the drone comb that they had in that first year. And they really went like bonkers. I mean, they built a ton more drone comb. And they did use it for the drone brood. So they were actually laying, the queens were laying drone brood. And you can see they actually have the 2 little blips. They're making a round of drones. They're having a break, and they're having a second round of drones. Yeah. And then the office colony, which is the swarm fiasco, this one as well, did a really good job of recovering post-swarm, but then has this second round of swarming and really just kicks the bucket. They also have this double dip of drone brood. It kind of swarmed itself to death, we could say. So this is what the data look like when you actually have all of them all together. This is written up in a manuscript. So if you'd like a copy of this, by all means I can send you a PDF. You can pore over it in whatever amount of detail that you want to. But yeah, so you kind of get to step back and kind of see things that are similar and things that are different. From my eyes, I really look at this drone comb and I say, okay, wow, they really do this double dip over here, drone comb, these double dips. Then you can start to think, okay, like why are they doing this? What's important about doing this? Why have all these colonies done these similar things? This colony here, the North colony, that was kind of a funky colony. They didn't really use their drone comb for anything but honey storage, but they were still rearing some drones in the worker comb, kind of like a last-ditch effort. So that's where it is. So at this point, you're going to say, okay, Michael, can you tell us anything that we didn't already know? Basically what you told us, here's what you told us. You told us that you set up a swarm, you get a lot of workers that die, then they recover, colonies are different, and they rear brood, and there's drowning. Okay, I understand, it's fine. You can be a little mean, that's okay. And there's a couple of things that I think, okay, maybe you didn't know, maybe you did know, but I can at least throw a couple of things. So when we think of colony growth and development, and this is for all social insects and all colony growth and development, we think of there being a couple different stages in a colony's life. You have a founding stage, an ergonomic stage, and then reproductive stages. And so you can think of this swarm coming in and investing. They've now chosen a home. They've built up. They build comb. Of course, Michael's obsessed with drone comb, so that's what he shows here as kind of a cool reproductive thing that they do. And eventually, they also reproduce by making new swarms again. So that's kind of like this kindly cycle of life. And the founding stage, so the founding stage is defined as when that colony first inhabits its site to when the first workers emerge. And the founding stage for a honeybee colony is actually quite short, because basically once that colony inhabits that site, the workers are building those very first cells. They have all their wax glands ready to go to build those first cells. The queen is laying in there immediately. They're very, very quick about making sure they can restart that colony growth. So that founding stage is actually quite slow. In a lot of other social insects, it takes a long time for the queen to rear those first workers. But in a honeybee colony, she's got the worker force for it, and they really invest heavily there. The ergonomic stage is defined as when the colony really grows rapidly, when there's lots and lots of workers being emerged, but they haven't yet invested in reproduction. And so for at least in this one, that ended from end of July to mid-August. Mid-August was about when those colonies first made investments in drone comb, so the first reproductive investment. But it actually overlaps with the reproductive stages because these colonies are investing in workers very heavily while they're also making reproductive investments. So unlike a lot of other social insects, they do workers, workers, workers. They stop, reproductive, reproductive, reproductive. In honeybee cases, they kind of blended the two, which is, hey, it's what they do. So I can tell you that 60% of that first year comb is built in the first month. So you really think of that swarm of bees, they're really rearing to go when it comes to building comb. And of course, that comb is what the colony is going to live on. If they don't have the comb, they don't have the storage space. They're really aggressive about getting a lot of comb in that first month. surprisingly, in the 4 colonies, 39 plus or minus 5 days that they start investing in drone comb. And keep in mind that this is mid-August. They were still building drone comb in mid-August. They are making that investment this year, even though they're not going to use it until next year. And the last thing was, the majority of these colonies that I didn't touch or I didn't do anything with, if the winter didn't kill them, they were definitely very keen to swarm, but not only just swarm, also after swarm. So as beekeepers, when we think of like swarming is something that colonies do, we should also think that a swarm is one thing, and a swarm plus an after swarm is another. These colonies that are living natural lives, they're probably swarming and after swarming, and maybe even after swarming twice. So that's in the reproductive size. So yeah, colonies like to reproduce. It's very important for them. It's important for us too. So here's, if you don't know this, all biologists are essentially obsessed with sex and reproduction. It's pretty much, they're all perverts. So when I think of these reproductive investments, on this side, I'm looking at the combs, and on this side, I'm looking at the brood. And what I'm looking at here is I'm saying, okay, when's that first moment that you invested in drone comb? And this is what I spent way too much time talking about yesterday. And that's this first little moment when the first little blip of drone comb appears. And if I say, okay, this is when the first drone comb appears, how many workers were in the colony when that happened? Because remember, everything in my research kind of ended up in like, wow, worker number is really important. And what I can tell you is in that first year, these colonies began building drone comb when the colony had 5,919 plus or minus 1,797 workers. Not one more and not one less. That's the number. There's no variation. No, okay, I'm joking. This is your ballpark figure. So once the colony had this many workers, they started making that reproductive investment. But in the second year, so now what we're looking at is when do you first start using that drone comb for something reproductive? This is still reproduction, but just a different stage of rearing reproductives. So how big were the colonies when they very, very first started rearing those drones? And that number was 5,592 plus or minus 805. But when you kind of step back and you look, I'm sorry if I'm blocking you, but if you step back and look at it, it's like, wow, 5,900 versus 5,500, they're both reproductive investments. They're both points when that colony can afford to invest in reproduction. Does that number sound familiar at all? It was the number that I actually found in my other experiments where I took the plot of all the different colony sizes and what proportion of drone comb they built. It's about at that switch point, 4,000, 5,000 workers. So when I look at this, I think like, gosh, what is it about that magic number of 5,500 something that lets a colony know, hey, we're doing pretty good. We got 5,500 workers. Maybe it's time to do a little reproduction. And of course, this is a question to answer. It's not, I don't got an answer for you, but I got, I can have another question. Another curious observation I made, so here you've got your colony. So this is not one of these colonies. These were all observation hives, but just to show that there's a colony here. And you have a colony that swarms. And when a colony casts a swarm, it's about 72% of the workers that leave with that swarm. But as I was collecting these swarms from these observation hives, and I'm just kind of looking at them, kind of taking a look, I'm noticing, wow, there's not a lot of drones in these swarms. And unfortunately, I wasn't able to do it with all of them because it was only something that occurred to me as I was doing this. And I took one of the swarms that I could actually say is, okay, this was the office colony. And the colony had over 2,000 drones. But if you count up the number of drones that ended up in the swarm versus the number of drones that stayed at home, only 5% of those drones left with the swarm. The vast majority of them stayed at home. And for me, as a biologist, that's really interesting because it's like, okay, you've got this colony, it's swarming. You got 70% of your workers just zipping out the door, and somehow the drones are just like you guys do your thing. I'm going to stay here at home. And so you might think there, okay, well, Michael, clearly initiating a new colony, starting a new colony somewhere else, it's a very risky endeavor. You're going to get to a new site, you have to build that new comb, you have to rear, collect honey. It's a very risky place. Yet the safest place to stay is at home. However, especially in this case, all these drones that stayed at home, 2 days later, the workers had killed every last one of them. There was a 4-centimeter layer thick of dead drones on the bottom of that colony. The workers were like, look, you're out of here. So staying at home is not the safest opportunity. And if you have children that are at home, you should let them know that Yeah. You should not kill your children. That's a joke. I'm just, he's a sick guy. Anyways, so another thing that I wanted to mention was so you may notice like, hey, Michael, one of those is called the office colony. Why is it called the office colony? So the north, east, and south colonies were all housed in the same room, and they had entrances that were facing north, south, and northeast and south, and they were kept in a room that was not climate controlled, but was allowed to get pretty darn cold. We kept the heaters would only go on if the temperatures were like 5 or 7 centigrade. So it was kept cold, and these colonies could still form a winter cluster. And one of the colonies, named the office colony, was in my office. And it's a great office mate, because you're sitting there and you can hear the buzz, and you can hear, when they're swarming, you can hear the quacking and all this. It's a really nice, it's a good office mate. It's much better than a human office mate. But there was a bit of winter weirdness. And by winter weirdness, what I mean is that my office is not kept at 5 degrees centigrade, and this colony was not forming that tight winter cluster. So much so that if you see these, so I enlarged this image so you could have a better image, so this is January, February, March, April. This is Ithaca, New York. It's freezing. This colony was still investing in some worker brood. They really were continuing with that worker production, so much so that if you see this honey area, they really ended up having just about no honey whatsoever. This colony I did actually feed a little bit, simply because I was like, well, shoot, if they die, then I don't have another experimental unit. But there is certainly some winter weirdness, and this is something that, of course, I thought of Derek's work as well. That like, how is this happening? That you have this colony, it's sensing the temperature, it's not really in tune with its environment. Whether that has to do with then its swarm madness the next year, I'm not sure. Of course, that's something that you need to do a lot more work on, but it's the kind of thing like, oh, wow, that's a curious thing. The other thing that's interesting about keeping a colony in your office is you think like, okay, the other room's cold, we should keep this room cold too. So I was like, hey, Tom, I've got an idea. What we're going to do is we're going to close the door to my office. We're going to put some tape along the door. We're going to open the window, and then we're just going to let my office be the same temperature as outside. And he, of course, is like, yes, it's for research. You can do that. And so I did it for about a week. And it turns out with central air that rooms are connected. And even though there wasn't a vent in my room, it got to the point where I was like, no, you're not cooling your office. You're cooling the entire building. And so we really had to close that window. And but it was unfortunate. But hey, you live and learn, and that's the way it is. So the other thing is, I mentioned about these colonies where you have a volume of area, and then it seemed like that these kind of like oddities where you have like these little peaks and like the things come and go, and you would think, okay, once they built some comb, it's not going to change. So do you remember what I meant? Like when I said take some salt with those lines where it's like they come up and down, and I'm the first to say that yes, there's a lot of variation when you have a comb that you're tracing and you're painting and then you're measuring. That's a lot of change. But what I ended up actually noticing was that some of these colonies actually were shrinking. So this is a picture of comb, and you can see there's 2 parallel combs here, and you can see this leading edge. This is the leading edge of the comb, and the workers are depositing more and more wax there. But if you actually watch this very carefully, in the late summer, the comb actually does shrink. You have that leading edge, it's like a thick tip, which is where they're going to expand. When you get close to the season when they're not going to be building more comb, they actually chew it back. So they actually do lose, about 1 centimeter almost everywhere. And you get this nice, interesting geometric pattern at the tip there. It's almost like what I would consider like a stop, like no more building here. So my first intuition was that I had made a mistake, but upon a closer inspection, it's actually that these colonies are shrinking a tiny, tiny bit. They're chewing out that extra edge. I would interpret this as that bees are extremely frugal with their wax. That it's a time of year that they're not going to be producing wax, and they will actually chew it from the edges to then use it elsewhere. But of course, this is something else that one could do more work on. So at this point, you might say, Michael, it seems like you've ended up with more questions than answers again. And to that, I would tell you that I'm a scientist, not a politician. So, if you want answers, you got to go to a politician. If you want questions, you go to a scientist. How are we on time?
We've got about 5 minutes and then a couple of questions.
Cool, that's great. But at least all this research can now be based on real phenomena, not things that you just kind of pulled out of the air. So this, I'd like to mention that the importance of sociometry and that all your research should begin with a thorough descriptive phase. So for example, if we have these 3 trucks and we want to compare how their fuel economy works, how fast they go, what kind of range they have, what they're capable of doing, shouldn't we first have a blueprint of those trucks? And the sociometry is like the blueprint of these colonies. I'm very well aware of the shortcomings of this research. I am basically working in a 2-dimensional observation hive versus colonies naturally live in a 3-dimensional space. Of course, if you want to observe your colonies without disturbing them, you kind of have to do it in 2D. It's a lot harder to do in 3D. But whether that's something that in the future we could do differently. Of course, sample size is low, and the location is all in Ithaca, New York. But there's no reason why people can't be doing these things other places. And yeah, I guess the last thing is if you do it really well once, you'll never have to do it again, which is a nice thing. And it's what I thought. But then later, I was like, I should do this again. So in May 2017, I actually did this again. I actually set up another round of colonies to look at, really focus on the density of workers and how that was changing. And this is unpublished data, so I really was only going to show you one slide. This is how the density of workers changes when they first start and they build up. And this is where the first drone comb was seen in these 3 colonies. And that's kind of what I'm working on now. I can also give you a couple quick things. Is some colonies actually did produce drones in their first year, if you start them early enough. Some colonies even swarmed in their first year, and this kind of shows the importance for colonies to start their life early. So that, a lot of thanks. Many thanks to the Blackslin family for supporting this, and I'll take any questions from you guys. Yeah.
Were the observation hives kept in the dark in your office?
So you have the colony, the panes of glass, and they have covers on either side.
Right.
So they're kept completely dark.
Did you use insulated covers to? Yeah.
Yeah.
Right, okay.
It's like 2-inch thick the foam.
Right.
Yeah.
So that would even out to some extent the different environments in which the hives.
Yes, but winter mortality. So all of these colonies died in their second year. When I thought we should turn the heat all the way down in that one room, and that was almost certainly a bad idea because it's very difficult for a colony to insulate themselves when they're in 2D versus 3D.
Do you think the construction of the single comb observation hive, would affect the distribution of the queen pheromone as compared with a conventional wild colony? And another thing, would that then reflect on the number of bees before they started giving a problem? The 5,000 that you quoted, would that then vary?
Yeah, so the question being that whether having a 2-dimensional nest versus a 3-dimensional nest would change the way that the queen pheromone is moving. It certainly could. In my case, I definitely did not keep track of it. That would be, you'd really have to do a very detailed experiment with that to show that. I do know that colonies will live perfectly happily in the side of a building and in one comb. So it's not completely out of their repertoire of abilities, but agree that it's not it's not the same. Oh, talk louder. It's not the same as being 3-dimensional versus 2-dimensional. I agree. Yeah. Whether it would have an effect on the reproductive investments, maybe.
Did you see any evidence of the colony changing the worker comb to drone comb in the same area or vice versa?
No, I did not see that. No, there was no case where I saw it. The experiments that have been done that have shown workers switching comb type from one to the other usually end up using very, very artificial, huge amounts of drone comb, and then they will tear it down and rebuild it. But at least in this case, it was no different. They kind of kept it the same.
Do you have information who gets out in the swarm? What kind of bees exactly? Because I have heard that sisters from a paternal side get together to get out. Is this true?
Oh, I think that's probably not. At least in this case, I wasn't marking individuals or marking different patch lines. So I can't answer from this research. But at least from what I've seen, I think that they generally do not do that. But it's something that you'd want to do. I'd have to look in to see what's been done so far.
What was your level of interference with the colonies? Did you feed? Did you treat? Was it just observation, or did you actually interfere in terms of management of the colonies?
So like true management. I mean, let's see. The one colony I did requeen it. One colony I did give it some feed when it was almost certainly going to starve to death. In the first year, we had a very, very poor goldenrod flow, so I did give some colonies feeders just so they could amass those amounts. They were treated for varroa, but to be honest, I don't think we would have even needed to treat for varroa, partly because they swarmed so much. So I mean, the management was pretty minimal, and that's kind of the point, is to leave it pretty minimal.
If we are doing shook swarm each year on our colonies, does that mean we're not raising drones that are going to be useful for mating with queens?
So you're saying, can you repeat the question, sorry?
If we are doing shook swarm on our colonies each year, does that mean we're not raising drones that are useful for mating with queens?
So what's a shook swarm?
It means a shook swarm for us, we take our queen out and we put all our bees on fresh comb.
Okay. Onto new foundation?
Yeah, we shake them on.
I'm not
But
sure.
then they've got to make new drone cells.
Yeah,
So
I
does
mean,
that mean they're not going to be useful for mating with queens?
depending on the size of the colony, they're going to be pretty good about making drone comb quickly. So if you've got a lot of bees and they're building a lot of comb, they will build that drone comb very quickly. And if they have the queen to lay the eggs, they will rear drones. But depending on the timing of when you're doing that, you might be limiting the number of drones in your area. But have one you have one beekeeper who's not, and then you might be okay.
The graph seemed to show, certainly I think in 3 of the colonies, there's quite a strong correlation between the proportion and the ratio of worker to drone comb. And I was interested that if you remove drone comb, whether that proportion would stay the same, and therefore your worker comb would reduce. And therefore, if you're reducing drone comb, say as part of integrated pest management, if there's an optimum amount that you should take out before it starts to have a negative effect on the colony.
So I think if you're using drone comb as a varroa suppressant kind of method, you probably should be removing all of it, simply because you don't want to be breeding the drones. You don't want to be breeding varroa in your drone comb. But by removing that drone comb, you now have a colony that essentially does not have any drone comb, so they're going to be very keen on building more drone comb. We also know that the presence of drone comb inhibits further drone comb building. So every time you take out that drone comb, you basically have a colony that says, wow, like, where's all the drone comb? And they're going to want to build more drone comb. So I guess if you are doing that method, taking out one to kill those drones and kill that varroa, but putting back another, you're in a better situation. Based on some work, so Tom's work on actually cutting down the trees and seeing the amount of drone comb, his range was about 17% drone comb. For these colonies, these observation hives, it was about 23% drone comb. So they're doing a pretty, I'd say 20% is a good rule of thumb of how much drone comb a colony would like.
You said that the comb had 2 sides in your observation hive. I've noticed your graphs show one side of the comb. Did you measure the other?
Yes. So the question was whether I'm measuring both sides of the comb. I am measuring both sides of the comb. But to visualize them, to show you guys what I'm seeing, I'm only showing you one side. When I calculate the actual comb areas, it's a question of whether, if you have a piece of comb this big, that's 10 centimeters squared of comb. But then comb surface, it has 2 surfaces. So actually measure both sides. The other curious thing was actually that if you look at one image, it looks like a mirror image of the other. They really are quite similar. And there's no doubt lots of reasons for that. But I do measure both sides.
If you put a rattan filter, a photographic filter, over the ant nest in a single sheet at around 400 nanometers, the ants couldn't see it, so they didn't put all garbage on the propolis on the inside of things, so you actually could still see it because they thought it was dark in there.
Yeah.
I'm not sure if that's useful to you, but a rattan 400 nanometer filter.
Yeah. So so the comment was about using a filter to block the light. So I actually use those covers, so they're kept perfectly dark. When I pull that cover off to trace out the nest contents, it takes me 15 minutes. It's pretty quick. But yeah, I mean, that's a great way to be able to actually watch.
You can see them, they can't see you, so.
Yeah, no, you have to think of your bees. Yeah.
Yeah, did you do any analysis on where honey was stored, worker versus drone comb?
Oof. Descriptive analysis, yes. So I definitely did a lot of descriptive analysis. Whether actually looking at, whether, you should come to my next talk at 2 o'clock. There's this guy I know, and he's, what have you done recently? Yeah, so I'll give a talk a little bit about that. I'm thinking specifically in this data set. It's a pretty rich data set. One could almost certainly do a lot more with it. I also would love to do a kind of a map analysis of where they organize different things. But no, I mean, there's definitely more that could be done with this exact same data set, and that's something I would like to do.